Okay, this video is a demonstration of solving simple rational equations. And I'm going to start with a simple example. I'm going to have 3 examples in this video. And just kind of talk you through what to look for, how to solve for the x, that sort of thing. They look like they're very difficult, but they're actually, once you get the idea, they're not too bad. So see if you can follow the reasoning that I'm using here, and then apply it to your, to your own problems and homework and whatever you might have. Okay, so whenever I look at a rational equation, again, let's talk about what that means. Rational equations. Remember that rational basically means ratio. So you have ratios or fractions in an equation. Okay, so instead of just whole numbers, you have fractions instead. Now the fractions can have whole numbers like this one does, or you can have regular polynomials like the later examples will, and I'll show you how to do those when we get there. Okay, so when I look at this, I'm asking myself, what's the lowest common denominator? What's the LCD, right? Because if I get the common denominator for all of those, I'll be able to start subtracting and adding, if I need to, the numerators. So when I look at this, I ask myself, what is the lowest common denominator for all 3 of these denominators? And if you said 6x, you would be correct. So now I'm going to multiply each one of these terms, each one of these fractions, by some kind of a 1 so that I can get 6x in the denominator. Let me show you what I mean. I'm going to multiply 2 over 3 by 2x over 2x. Look what happens when I do that. I'm multiplying this by 1, right? But I'm not changing. When you multiply by 1, you don't change the value of 2/3, but you change what it looks like. That's going to be 4x over 6x. That's still equal to 2/3, but now I have 6x in the denominator. Now, using that same idea, what am I going to multiply 5 over 6 by? Multiply by x over x. Again, remember, multiply by 1 doesn't change the 5/6, but it does change the denominator, doesn't it? So now I have 5x over 6x, which is basically the same thing as 5/6. And let's do this last one. What do I need to multiply this one by in order to make it equal to 6x? Well, the answer is just 6 over 6. And down here, I'm going to get 6 over 6x. Now, once you've done that, you've transformed the original equation into the same base. Each one of these has the same base. Each of these did not, so I wasn't able to do anything with them. Each of these does. The cool trick about solving rational equations is once you get the bases to be the same, you can cross them out. Great trick. I love that. And then you get to rewrite the numerators. You'll get 4x minus 5x is equal to 6, and that becomes a bit of a simple problem, doesn't it? I can make that just negative x is equal to 6, or x is equal to negative 6. And you can go back up to the original equation, plug that in, and you'll see that it actually works. Okay? You probably also want to find the restriction here. X cannot equal 0. And that's just to find out that x is, all the numbers are possible to be put into the x except for 0. You can't put 0 into that because then you'll be dividing by 0, and that would not be allowed. Okay? So here's your final answer on that one. Now let's take this very same procedure and do it in a slightly more difficult problem, okay? All right, so let me just move that up to the top there. Okay. Now let's ask ourselves the same question. I want to try and add these two and make them equal to 2. But I can't do anything because the bases are all different. And remember that the whole number has a base of 1. So what is going to be the lowest common denominator for all 3 of these terms? And if you said 15x, you would be correct. Okay, so what can I multiply 3x by so that it equals 15x? And I don't change the value of that. Well, the answer is 5 over 5. Make sense? Because multiplying by 1 doesn't change that, but it does give me a denominator of 15x. Let me do the same thing with this one. If you said 3 over 3, you're correct. And this one is going to be 15x over 15x. Remember, we get to cross out the denominators. And now, for my second step, I'm just going to rewrite the numerators. So it's 5 times x plus 4 plus 3 times x plus 8 is equal to 2 times 15x. That equation is equivalent to my initial problem. And look at that, I've gotten rid of all my denominators and it's going to be a lot easier. You're going to be able to do that with every single rational equation. This becomes an easier problem to solve. Let's distribute. 5x plus 20 plus 3x plus 24 is equal to 30x. Let's gather up our like terms. That's going to be 8x plus 44 is equal to 30x. Let's subtract 8x from both sides. 44 is equal to 22x. Boy, this is really turning out to be even easier than I thought. Divide by 22 on both sides. And your final answer is x is equal to 2. Now again, go back up and find the restrictions. Remember what a restriction is. A restriction is whatever number I put in for the x that will make a denominator equal to 0. In this case, it's pretty easy.
Report to the dean's office.
X cannot equal 0 in this one either, because if I put a 0 in for this x, this denominator becomes 0. If I put a 0 in for the x, this denominator becomes equal to 0. You don't have to worry about the numerators, just the denominators. Okay? So that would be my answer for this problem. Let's do one more, making it a little bit more complicated.
Richardson, please report to the dean's office. Richardson, to the dean's office, please.
Okay, now when I look at this one, I've got something a little bit more complicated, right? I've got a binomial here, a binomial here, and then I've got a difference of squares, another binomial here. I'm going to have to factor this first before I can figure out how to make the bases all the same. So let me just rewrite this first part. And I'm going to factor, you have to remember how to factor a difference of squares. Well, in this case, it's going to be x plus 5, x minus 5. Now, once I've done that, now I can compare my denominators a lot better. What's going to make this denominator look like this one? And if you said x minus 5, you're absolutely correct. So let's put in x minus 5. Remember, you're just multiplying by 1. You're not changing this. You're just changing it so that it has a different denominator. What's going to make this denominator equal to this one? It's going to be x plus 5. Now all three denominators are exactly the same. All my numerators have been jumped up proportionally now, so they're all equal to the original problem. And remember what you get to do when all the denominators are the same. You get to cross them out. Well, that's going to really make this problem a lot easier. Let's give this a shot. It's going to be 2 times x minus 5 minus, don't forget the minus sign there, and this is going to be a little tricky. You're subtracting the whole thing that follows, which is 1 times x plus 5. Now the reason I did it that way is because I'm going to have to distribute that negative, right? If I had just put down x minus 5 the way it looked, It looks like I would have been just subtracting the x and not the 5. So be careful on that one. And that should be equal to 16. Let's keep going on this one. This is, again, this problem is basically the same thing as this problem, but now I don't have any denominators, so the x's will be the correct answer. So let's go ahead and distribute. 2x minus 10. Let's distribute that negative. Minus x minus 5 is equal to 16. Gather my like terms. 2x minus x is x. Minus 5 minus 10 is minus 15. Let's add 15 to both sides. X is equal to 31. And if you went back and plugged that in, you'd find that that's the correct answer. Now don't forget, got to find the restrictions here. Now go back to the original problem, because that's where you always have to go. What number would make this denominator equal to 0? Negative 5, right? So I can't use it. So I'm going to restrict negative 5. What number is going to make this denominator equal to 0? Positive 5. So I can't use it. And basically that's just the same thing. If you look at that, positive 5 and negative 5 would be the restrictions for this denominator. There's your answer. Okay, good luck on that. I'm going to put a couple more videos on solving a little bit more complicated rational equations, and hopefully that'll help. But the idea is the same. Remember, find a common denominator, multiply by 1. You have to have them factored, though, first before you can figure out what the common denominator is. Cross out the denominators when you've got that, because you've got your equal sign, and then you've got a simple problem, solve for x, or whatever variable you're looking for. And then go back to the original problems and see which numbers will make them, which numbers you need to have for restrictions. Okay, good luck on this.